Hi, my name is Baran Haydari and this is my submission for CLO 835 Assignment 2. In this recording, I'll demonstrate my full Kubernetes setup, deployments, services, and logs, as well as show my GitHub repo history and structure. I've used a local single node Kubernetes cluster created with Kind, and it's running on my AWS Cloud9 EC2 environment. The project includes two main components. One of them is MySQL database and the other one is Flask web application. Both of them are deployed in the Kubernetes cluster under the web namespace. I'll start by showing that my cluster is up and running. Here I run. You can see my Kind cluster named CLO 835. The Kubernetes control plane is running at HTTPS 127.001.37.067, and my single node is named CLO835 control plane with internal IP 172.18.02. This confirms that it's a single node cluster with all core components running, including etcd, kube server, controller manager, scheduler, and kube proxy. The operating system is Debian GNU Linux 12, and the container runtime is Contain version 1.7.15. This setup satisfies the requirement to demonstrate that all Kubernetes components are active and healthy. Next, I list all namespaces with kubectl get ns. Here we can see default kube, system kube, public, local path storage, and my custom namespace web. Then I show everything running across all namespaces with this command. The output shows the system pods like core DNS, etcd, kube, app server, API server, and also my own deployments for MySQL and web deploy inside the web namespace. Both are in the running state, meaning my deployments are healthy and reachable. Now I'll describe deployments to show the environment variables set for both MySQL and the web application. First, for MySQL, the environment variables include MySQL database named appdb, user app, and the password app pass, and the root password root pass. These are not the real credentials. So then for the web app, it shows the host name and the username, the password, and the database name. This confirms that the web app can connect to the MySQL service using internal DNS resolution inside the cluster. Next, I'll show the services I've created. Here we can see MySQL service is cluster IP on port 3306 used internally by the web app, and the web service is a NodePort exposed on port 3001 map path to port 80 in the container. I will also explain one of the assignment questions here, which was asking, can both applications listen on the same port inside their containers? And the answer is yes, because each container runs in its own isolated pod network namespace, so they can both use port 80 internally without conflict. The NodePort just exposes the web app externally. Now I'll be showing the application logs to prove connectivity between the front end and the MySQL database. First, I will be forwarding the port. Okay, I will just open it on the browser. As I had it open before, I'll just refresh the page. And we can see that it's showing CLO 835 app, color blue, and the database status is showing okay, confirming that the web app connects successfully to MySQL. I also show the logs again. We will also be checking the time right here, and we can see that both of them are running. Now I'll demonstrate rolling out an updated image version of the web app. First, I build and push a new Docker image. The output shows deployment web deploy successfully rolled out. When I check again, I see the new pod name is running in running state, and this confirms a smooth running update with zero downtime. I also recheck logs to confirm the new container is running properly and responding to requests. Now I'll show my GitHub repo to verify my project structure and progress. This one is my Flask app and Docker file. Here I'll just open some files to show the work, and also I would like to mention that all the passwords on the website are not the real passwords. And here is my SQL, the Docker file. And also all of these passwords are not the real passwords. I'll go back to show the K8 folder that is holding my SQL deploy and the web deploy. Okay, so Kubernetes manifests for MySQL and web deployments. Now I will be showing my commit history using. I will first enter to the right folder to get the right result. The log shows 3 commits. First is initial commit for assignment 2 that it was created on October 24th, which is before the assignment due date. Final version before submission committed on October 25th, also before the deadline, and added academic REMI committed before submission and the deadline. I also verified that no sensitive environment variables or passwords appear in my code or YAML files. I also confirmed my repo, like the GitHub repo commit times are well before the deadline, and that the commit messages are meaningful and reflect real progress. And finally, to summarize my demonstration, in this assignment I successfully created a single node Kubernetes cluster on AWS Cloud9, deployed both a MySQL database and a web app, connected them via internal service, exposed the app externally via NodePort, verified the database connection, rolled out an updated image, and confirmed everything through logs and browser testing. Finally, I showed my GitHub repo with proper commit history, timestamps, and clean code structure. And yeah, that's it. Thank you for watching my demonstration.